Hello there, students. Mr. Dunaway here. Welcome to 8-2. It's time to dive into the world of two-step equations. So we are going to be using what you know, hopefully. Go ahead and put your name on your notes. If you don't have them, you can just copy them down on a regular piece of paper. Hopefully I have put them on my website. If not, just like I said, use a regular piece of paper. Well, this is all based on things that we've been talking about in class. We're now talking about two-step equations. You've only been doing one-step equations up to this point. That means that you've only had to do one thing to get to the answer. These are all questions that are going to require you to do two steps. That's why they're called two-step equations. All right, two-step equation contains two operations. In other words, there are two things that are happening to the variable. And to solve the two-step equations, you have to undo each operation in the reverse order of the order of operations. That's actually a really good way to explain what we do. You undo each operation in reverse order of the order of operations. All right, here's an easy way to think about it. The first thing you always do in a two-step equation is you undo the addition or subtraction. All right, you're either going to have something added or subtracted to the variable. So you always do that first. Do that first. If you don't do that first, you're going to end up with fractions and decimals. You might have fractions or decimal answers anyway, but this way at least you won't have to work them throughout the problem. So undo the addition first. It gets quite complicated if you don't. Even more complicated than it already is. Step two is that you will have multiplication or division that you have to undo. So second thing, undo the multiplication. Not sure if I can spell today. All right, and then it might be division also. Okay, so you're going to have one or the other. So you're going to have addition or subtraction in there, and you're going to have multiplication and division. And then just remember the thing that I've always been saying, you always do the same thing to both sides. As long as you do that, everything should work out fine for you. All right, so let's just dive right into things here. I'm not going to work through all of these questions. That would be take too long. Let's begin with putting a line or a dotted line down. Recall, we have two sides to an equation here. All right, looking back at my notes, it says the first thing that we have to do is we undo the addition or subtraction. All right, if I look at this question, number one, and I say to myself, what's happening to P? There's two things. It's being multiplied and it's being added. Okay, so we have to undo both of them in reverse order of the order of operations, and that basically means normally you would add before you multiply, so you undo the addition first. All right, again, just go back to step one. Always undo the addition. So this problem has plus 9, so we are going to subtract 9. All right, now I like to think add negative 9. I'm going to stay consistent with that, but we're just subtracting 9 here. All right, so if I subtract 9 minus 9, that is 0 right there. So I'm left with this 4p. He's still on that side, so let's copy that down. Keep your equal sign on the line. Please keep your work neat, just like I'm doing in the video. 25 minus 9, or plus negative 9, is equal to 16. And then what we're going to do is we're going to look at this line, and notice what we have. We have 4 times p. All right, we have multiplication of the variable, so we undo that by dividing by that number, just like we did last week. 16 divided by 4, do the same thing to both sides. Don't forget that. All right, there's your 1p right there, or you can just put p. 16 divided by 4 is 4. And guess what? That's the answer. That's the answer to the problem. Let's dive right into number 2 here. Keep things moving. All right, take a look at number 2. Please pause the video as needed. If you need to review things, do that. But we're going to do a few examples here and then call it a day. Negative 2x plus 1 equals 7. Okay, what's the first thing we do? I hope you're saying undo the addition or subtraction. That's right. We got plus 1 happening right here, so we're going to subtract 1, or you're going to think add negative 1 to both sides. And when I do that, straight down, 1 plus negative 1. Hey, guess what that is? 0 pair. Goodbye. Negative 2x is here. Equal sign right on the line. 7 plus negative 1 is 6. You got negative 2 times x equals 6. Divide that by negative 2. All right, there's negative 2 divided by negative 2. That's your 1 right there. There's x. All right, and 6 divided by negative 2. 6 divided by negative 2 is negative 3. There it is, right there. Now, Now, just to show you, we can check these, and you should. You should always check your answers on a test or an exit slip by substituting x into that value and see if it works. So I'm not going to work out number 3. I am going to, so I'm going to use my check. I'm going to show you how to do the check over here. The original equation was -2 times x. I'll just write it down here. It's -2 times x plus 1 equals 7. All right, I'm going to substitute for x -3. So it means -2. -2x means -2 times -3 plus 1. Now, if I go -2 times -3, order of operations says I multiply first. That's +6 plus 1, which is 7, which is what it said there. So there it is. There's my check. Guess what? That's worth a happy face right there. All right, let's keep the ball rolling here. Let's go on down the page to number 4. Number 4, uh-oh, they put x on the other side. Do you think that matters? No, it does not matter. It doesn't matter which side x is on. All we want to do is get 1x by itself, and that's how you win the game. All right, let me give myself a little more room here. I might need it. Okay, so recall what we do. We undo the addition or subtraction here. So I've got -4 right there. I could change it to addition. I could go plus -4. But this one's easy enough. I can just think I'm going to add 4 to both sides. I'm going to add 4 to both sides. There we go. All right, because we undo the addition first. All right, so it's -4 plus 4 is 0. And so we're left with 7x on that side. And 17 plus 4 is 21. All right, divide that by 7. Divide that by 7. X equals 3. All right, this would actually be a good time to pause the video. See if you can do the check step. That is the answer here, but put 3 in for that part of the problem and see if you can end up with 17. Pause the video to do that if you want to. And also, I'm going to keep talking here, but I would challenge you, try pausing the video and working out number 6. I'm going to skip number 5. Try working out number 6 and see if you can work that one out. But there's a little tricky thing in there that I haven't talked about. See if you can figure it out. If you have the guts, try it. But I'm just going to keep going here. So let's look at number 6. Here's the trick. If you paused the video and tried it yourself, if you got confused, this might be what happened right here. There's subtraction. What do I always say about subtraction? I know I didn't do it over here. I very well could have. I could have said boom, boom on that and made that plus -4. That's what you should do right here, plus -3z. You need to do that. Otherwise, you're going to end up with a sign error if you lose track of that negative sign. All right, divide our paper right here. And let's get going here. We undo the addition. What's happening to the variable here? 2 things. It's being multiplied by -3, and it's being added to 5. So you have to undo what's added. It doesn't matter where it is. It's what is happening to x. It's adding 5, so we are going to add -5, or think subtract 5. Now in this problem, if you're thinking subtract 5, which is what you're doing, you want to think add -5. Otherwise, I just continue to see errors of people adding these numbers wrong because of that negative sign on the 13. Okay, that's 0 over there. So this side, the right-hand side, is left with -3z. Does not matter which side it's on. -13 plus -5, that works out to be -18. Don't forget your equal sign in between. Those 2 sides are equal. Now, I've got -3z times z. We're going to undo that, right? It's being multiplied. We're going to divide by that number times the variable. Do that to both sides. Equals z is equal to +6, because it's a negative divided by a negative is +6. Right there it is. Z is equal to 6. Doesn't matter which side it's on. All right, I've hit 9 minutes. I do want to do a couple problems on the back, so I'm going to stop this video and resume starting on number 7 here in a moment.